All right, the first type of example we're going to work on here is a fraction problem. And you can see here with our system of equations, there are lots of fractions in these problems. As we go through these problems, you may want to pause and go back and make sure that you understand each step. The first thing you need to do is maybe pause the video right now so that you can get this equation written down in your notes, or sorry, this system of equations written down in your notes. Okay, we're going to move on from there now that you have this written down in your notes. Okay, I see that in this very first equation I've got these two fractions and then I have three fractions in the second equation. I really don't want to deal with the fractions, even though I could use my elimination method and figure out what I can multiply by and all that. I really don't want to deal with the fractions if I don't have to. So what I'm going to do is show you a method to get rid of these fractions from the beginning and then solve the system without any fractions in it. What I can do is I can look at the fractions and I can look at the denominators and I can multiply by the least common denominator. So when I'm thinking about that, I'm thinking about the smallest number that 2 and 3 goes into evenly. Okay, and what we know is that that number is 6. So I'm going to multiply this entire equation by the number 6. Okay, you may need a calculator to do this, all right, but 1/2 of 6 is 3x. Okay, 2/3 times 6, that's like dividing by 3 and then multiplying by 2. So 6 divided by 3 is 2, times 2 is 4. So plus 4y equals, and now I have to multiply this part as well. 6 times 2 is 12. Okay, so now that's kind of nice. All of a sudden, I have no fractions left in that problem. Let's do the same thing for the next problem. Okay, in this problem, I have three denominators, 4, 2, and 3. I need to find the least common denominator for all three of those numbers. So the smallest number that 4, 2, and 3 all go into evenly. 6 doesn't work, only 2 and 3 go into 6. We might think 8 because 4 and 2 both go into 8, but that 3 doesn't go into that. The smallest number that all three of these share is 12. Okay, so the least common denominator is 12. So let's multiply through. 12 times negative 1/4 is negative 3x. 12 times 1/2 is positive 6y. And 12 times 2/3, again, it's like dividing by 3 and multiplying by 2, is 8. Okay, now we see we have this nice system of equations set up for the elimination method. The x's line up, the y's line up, and the equal signs line up. Okay, so we have a nice system of equations that we're ready to solve. I already see that I do have opposites, so I'm actually ready to go ahead and add these two equations together. If I didn't have opposites, I might need to multiply one or both of the equations again so that they would have opposites, so I'd be ready to add them together. 4y plus 6y is 10y. 12 plus 8 is 20. Now solving for y, divide both sides by 10, so y equals 2. Okay, and I'm halfway to my answer. Now normally what we say is take this number and plug it back into one of the original equations to solve for the other variable. But honestly here, I don't want to go back to one of these original equations because they've got all these fractions and it's really messy. So instead what I'm going to do is I'm going to choose this equation here to go back to find out what x equals. So 3x plus 4 times 2 equals 12. Okay, again, I was plugging my 2 in for the y in that equation. So 3x plus 8 equals 12. Okay, I'm going to subtract 8 on each side. All right, so 3x equals 4. All right, and I am going to get a fraction for my answer, it looks like here. So x equals 4/3. Okay. All right, so what we see there is now I have my x and my y, and again I can write my solution as an ordered pair. 4/3, 2, okay, for my final answer.